Hello students, in this video I am going to discuss some important topics related to your ICSE examination. Now there are certain topics which appear in every question paper. So that is what I am going to discuss in this video. So these topics you must learn, should not skip. First of all, it is the definition of atomic size. What is atomic size? It is defined as the distance from the center of the nucleus to the outermost orbit of an atom. This definition can come in any form, in a multiple choice or in any kind of matching or in fill in the blanks or in any form it can appear, and even sometimes as definition. Now next definition is ionization potential. It is the amount of energy required to remove an electron from the outermost orbit of an isolated gaseous neutral atom. The same in this definition also, any form of question can be framed. The third definition here is electron affinity. It is the amount of energy released when an atom gains an electron in its outermost orbit in the isolated gaseous neutral state. The fourth definition is electronegativity. It is the tendency, the important word, tendency of an atom to attract the shared pair of electrons towards itself when combined with another atom. The next definition is metallic character, is the tendency of an atom to lose electrons. So these definitions you must learn, you should not underestimate it. You must learn, write and practice so that you will be able to write without any mistake, without missing any key term. Now some properties. There is a summary of the periodic properties. You have learned across a period the atomic size decreases. So a downward arrow I am putting to show decreases. And down a group, that is from top to bottom in a group, atomic size increases. And then ionization potential across a period increases, and down a group it decreases. I have already dealt with this all in detail in the videos of the chapter. You can check it on the playlist. You can find out the chapter. There all these details are there. Electron affinity across increases, and down a group it decreases. Electronegativity across a period increases, and down a group it decreases. Similarly, now let us take the next property, metallic character. Metallic character across a period decreases, and down a group it increases. The most metallic element will be at the bottom of any group or on the left hand side of any period. Then the non-metallic character, if you check, it will increase across and decrease downwards. So these are periodic trends. You must know this because the trend can be asked what happens to the period, or they can give you a set of elements in a period and ask which one is the most metallic element. It will be on the left hand side. So you can find, if you know this sequence, you will be able to answer these questions. The next is electrovalent or ionic bond. What is electrovalent bond? A bond formed by the transfer, the word transfer is important, of electrons between two atoms. Similarly, what is the definition of covalent bond? Bond formed by the mutual sharing of electrons between two atoms. Example, oxygen molecule, chlorine molecule, etc. Then coordinate bond. What is a coordinate bond? The definition you must know, bond formed by the sharing of electrons between two atoms. Here the word mutual is not used, please be careful. In covalent bond we use mutual sharing. Here sharing of electrons between two atoms in which only one of the combining atoms contribute both the electrons for sharing. Whereas in covalent bond mutually both the atoms are contributing. So it is mutual, here it is not mutual. Okay. Now the next question that can be asked is the molecular structure. Example, structure of ammonia can be asked. Structure of ammonia is nitrogen molecule combined with 3 covalent bonds with 3 hydrogen atoms. This is the molecular structure, and there is a lone pair here. This is the structure of ammonia molecule. If the electron dot figure is asked, then you should be able to make this. So it will be 5 electrons on nitrogen, and 3 electrons from 3 hydrogen atoms is shared, and there is a lone pair. So the nitrogen is reaching octet, hydrogen is reaching duplet. Structure of ammonia molecule, this can be asked. And the next structure that can be asked is methane. Methane is made up of a carbon atom with 4 hydrogen atoms, 4 covalent bonds. So this is the structure of the molecule. And if the electron dot figure is asked, carbon has got 4 valence electrons, and then one hydrogen has 1 electron, so 1 covalent bond, next hydrogen, another covalent bond, the third hydrogen, one more covalent, and fourth another covalent bond. So this is a structure, electron dot figure of methane molecule. Okay. Now carbon tetrachloride. Carbon tetrachloride is 1 carbon atom with 4 chlorine atoms. 4 covalent bonds are formed there. Okay. And what is the electron dot figure? Carbon with 4 electrons, valence electrons. And there are chlorine atoms. Chlorine atom has 7 valence electrons. Remember to make 7 electrons. 1 electron is being shared. Many children make the mistake of making only this electron and forgetting the remaining 6 electrons. That is wrong. Chlorine has 7 valence electrons. The next chlorine atom comes here. Here also there are 7 valence electrons. Only 1 is involved in the bonding. And the third chlorine atom, there are 7 valence electrons. 1 is involved in bonding. The fourth chlorine atom, 1 is involved in bonding, and there are 3 lone pairs here. So this is carbon tetrachloride molecule, electron dot figure. The next is ammonium ion. Ammonium ion is nitrogen with 3 hydrogens having covalent bond, and the fourth one is a coordinate bond. So you have a hydrogen here which has no electron and a square bracket with a positive charge. This is ammonium ion. Please remember to make 3 covalent bond and 1 coordinate bond and a positive charge in the entire molecule. Then if you make the electron dot figure, it will be nitrogen atom with 3 electrons on 3 sides and a lone pair here. Now here the hydrogens are having covalent bond. Maybe you can use star for this. So 3 hydrogen atoms. So 3 bonds. The fourth hydrogen does not bring any electron. It is an H plus ion. It's a proton. The lone pair is being shared. So there will be a positive charge. So this is the electron dot figure of ammonium ion. And then hydronium ion. Hydronium ion is hydrogen combining with oxygen. So water molecule. And there is a third one which is a lone pair. And here is another lone pair. So this is hydronium ion. Now if you make the electron dot figure, oxygen atom is in the center, which has got 2 lone pairs, and there are 2 bond pairs. Hydrogen is combining, another hydrogen is combining. This is water. Now here is a lone pair, a proton, that is an H plus ion which has no electron, has come here. And so this entire thing will have a positive charge because this does not bring any electron. So this is the coordinate bond. The other lone pair is still there, unbonded. Okay. So now understand this is hydronium ion and ammonium ion. Out of these two, one of this will be there in every question paper. You check any question paper. So if you learn these 2 structures, 1 mark is guaranteed. So any one of this will come. Sometimes both can also appear in the same question paper. And then let us move into electrovalent and covalent compounds, the properties. Electrovalent compounds are solids with crystal lattice structures at ordinary temperatures, whereas covalent compounds are generally soft solids, liquids or gases. Okay. Now electrovalent compounds have high melting and boiling points. Covalent compounds have low melting and boiling points. Now electrovalent compounds dissolve in polar solvents, but they do not dissolve in non-polar solvents. And whereas covalent compounds dissolve in non-polar solvents but are insoluble in polar solvents. This is a general trend. There are exceptions. Then conduction of electricity. Electrovalent compounds conduct electricity in the molten or aqueous state. 2 states in which they conduct, molten or aqueous state. But in solid state they do not conduct. Whereas covalent compounds do not conduct electricity in any state because they cannot form ions. Okay, these are the general things. Now there are exceptions also. These properties you must know because number of questions can be framed on the basis of these properties. Now next is the electrolyte, strong electrolyte, weak electrolyte and non-electrolyte. Strong electrolytes undergo complete dissociation in molten state or aqueous state. Okay. Therefore, they consist only of ions. Almost every molecule is ionized, so only ion is there. And they conduct large amount of electricity. Whereas weak electrolytes undergo partial dissociation. Means if there are 100 molecules, only a fraction, that is 50 or 60 molecules will dissociate, the others will not dissociate. So there will be ions as well as molecules both in the molten or aqueous state of these weak electrolytes. So they conduct electricity partially, or small amount of current is conducted. Whereas non-electrolytes, no dissociation in molten or aqueous state, and they consist of only molecules and do not conduct electricity at all. So one thing important to note here is strong electrolyte has only ions in molten or aqueous state. Weak electrolytes have ions as well as molecules in aqueous state or molten state. Non-electrolytes have only molecules in any state. So this difference you have to understand. Then definition of electrolysis. What is the definition of electrolysis? It is a process and decomposition takes place. A chemical substance in molten or aqueous state, current is passed, and then formation of ions which will be discharged as neutral atoms at the respective electrodes. The last part you may ignore. Even if you don't write, the answer will be correct up to this current. That is, electrolysis is process of decomposition of a chemical substance in the molten or aqueous state by the passage of electric current. So this definition also you must know. Then principles of electrolysis. These things you have to know so that you will be able to answer questions. There may not be direct questions on this, but this concept you have to have in your mind so that you will be able to answer questions. When the current is switched on, anions migrate to anode and cations migrate to the cathode. This happens when current is switched on. When current is not switched on, nothing happens. Electrons are neither created nor destroyed during the process of electrolysis. That you have to know. So whatever number of electrons are there in the beginning will be there in the last end also. Number of electrons lost by cathode. Cathode is negatively charged. It has got excess of electron, so it will lose electrons during reaction. And the same number of electrons will be gained by the anode. So no electron is destroyed. No electron is created. So whatever is there from cathode, it is transferred to the anode. That's what is happening. The products of electrolysis are formed at the electrodes only. Now anode means oxidation. Always relate this. Anode, oxidation. And oxidation is what? Loss of electrons by a substance is oxidation, and it happens at the anode. And reduction at cathode, reduction is nothing but gain of electrons. Okay, so this is what you have to understand. Then some give reason questions can be asked on from this. Number one is solid sodium chloride does not conduct electricity, but its aqueous solution does. So what will be the answer for this? So solid NaCl, solid sodium chloride, absence of mobile ions, absence of mobile ions. So no conduction. Please understand. Okay. So for conduction of electricity, mobile ions are essential. Now what is asked then? It's aqueous solution. So aqueous NaCl, presence of mobile ions, presence of mobile ions. So conducts. Okay. So this is how you have to differentiate and answer this question. Okay. Then solid magnesium chloride does not conduct electricity, but its molten state, it conducts in molten state. The same answer comes here. Solid MgCl2. Okay. Absence of mobile ions. Absence of mobile ions. And the next is molten MgCl. Molten MgCl. Molten means heated to melting. Presence of mobile ions. Okay. So here no conduction, conduction. That even if you don't write, it's okay. Now understand one thing. No conduction means absence of mobile ions. Conduction happens means presence of mobile ions. This is the keywords. Okay. Understand that. Then examples of electrolysis. Here we have the example of molten lead bromide. We have studied molten lead bromide. The cell, electrolytic cell is made up of silica. Silica crucible is used. Okay. And what is the anode? Anode is made up of graphite. Okay, and what is the cathode made up of? Cathode can be graphite or iron. Okay, then the lead bromide PbBr2, what is the reaction? It dissociates to give Pb++ ions and 2 Br- ions. So these are the ions produced. Now at anode, what happens? The anions migrate to the anode. Okay, so Br- will migrate to the anode. It will give its electron to the anode and form neutral bromine atom. Okay, and then what happens at the cathode? The cations Pb++ will migrate to the cathode. Cathode has excess of electrons. It will give 2 electrons to it. There is a deficiency of 2 electrons. 2 positive means deficiency of 2 electrons. It forms neutral Pb. Okay. Then we have seen number of electrons lost by cathode is equal to number of electrons gained by anode. So here the cathode is giving 2 electrons. So the anode will be taking 2 electrons. That means this equation should be multiplied by 2. So 2Br. Okay, 2Br will later change to Br2. Okay, so this is what is happening in this reaction. Now where is the oxidation? As substance is losing electron in the anode, here it is bromide ions are losing electrons, so it is oxidation related to anode. Cathode, the substance is gaining electron, so it is reduction. Okay, so overall the reaction is redox because oxidation and reduction are happening simultaneously. So this is the reaction of molten lead bromide. And then we have electrolysis of aqueous copper 2 sulfate, CuSO4, which is dissociating to give Cu++ and SO4 minus, and water will also dissociate. In this water, H2O dissociates to give 2 H+ ions and only one H+ ion and OH- ions. Okay, so here we have the dissociation. Now what is the anode and cathode? Made up of copper. Anode made up of copper. Okay, so copper is an active anode. So what happens? It will produce its own ions. Copper will give Cu++ and 2E-. We have already studied this. You can go back and watch the video under electrolysis. You can check the playlist where you will find it. And then anode, what happens here is the anode also is made up of copper. Here Cu++ ions come and they take 2 electrons and change to Cu. So the reaction at anode and cathode, they are converse of each other or reciprocal to each other. The opposite reaction happens here. Okay, and whereas H+ and OH- ions and this SO4 ions, they have no role in the reaction. This is what is happening in aqueous copper 2 sulfate when copper electrodes are used. Then electrolysis of acidified water. Water we know dissociates to give H+ and OH-. So this happens when water is slightly acidylated, small amount of acid is added. The acid added will be H2SO4, dilute sulfuric acid, because it does not interfere with the reaction. Because pure water is a non-conductor, it does not produce ions. Okay, the presence of sulfuric acid enables water to ionize, producing ions. Now what is the reaction at the cathode? Cathode we have H+ ions and it will take an electron and form neutral hydrogen atom. Anode we have OH- ions and it will give OH plus electron. Okay, now OH is unstable, so 4 OH will change to 2 H2O plus O2. So 4 OH means this will be multiplied by 4, 4 OH minus 4 OH and 4 electrons. Since there are 4 electrons in the anode, this also will be multiplied by 4. So 4 and 4. So that means 4H means it will give 2H2. So the ratio of product 2H2 and 1O2. 2:1 is the ratio. Cathode reduction is happening, anode oxidation is happening. So these are the simple reactions of acidulated water or acidified water. Then we have electroplating of an article with silver. Electroplating is coating of a superior metal over a base metal or an inferior metal. Purpose is to prevent rusting or corrosion and to give an expensive look to the article. Okay, so this also we have discussed under electroplating. There is a video on the name of electroplating. You can go electroplating with silver, electroplating with nickel. Both are discussed separately. You can see there. The cathode will be the article. The cleaned article will be the cathode, and anode, because we are coating with silver, will be a block of silver. Okay, so the silver, the anode is the principle of active anode is involved. The anode silver will give Ag plus ions and electron. Now the article at cathode, what happens is cathode, the cation Ag plus will come here. It will take an electron from the cathode and it will form Ag. So both the reactions are opposite. Here the ion is forming the metal and here the metal is changing into ion. So this one is reduction and this one is oxidation. So overall it is a redox reaction. The anode loses mass as the metal is continuously changing into ions. Cathode gains mass because the silver ions get deposited over the article in the form of metal. So weight lost by anode. Weight lost by anode is equal to weight gained by cathode. Okay, cathode gains weight, anode loses mass. Okay, so this is it. Now what is the electrolyte used here? Here sodium argentocyanide is used, NaAgCN2. Okay, so this is being used, sodium argentocyanide is used. Okay, and now let us see the electroplating of an article with nickel. The same thing happens here. Cathode will be the cleaned article and anode, what happens here? We are using the block of nickel because we want to coat nickel, block of nickel. Okay, so what is the reaction? Ni will change to Ni2 plus and 2 electrons. It is a dipositive cation. Here it is unipositive. Now article will, here what will happen? The Ag plus, the Ni plus plus ions come here. They take 2 electrons and change to nickel. Okay, so this is reduction and this is oxidation. Same thing applies here. Weight lost by anode is equal to weight gained by cathode because the anode continuously loses mass as the metal is changing into ions and moving into solution, and the nickel ions will go to the article at the cathode and there it is getting deposited. The cathode gains mass. Now what will be the electrolyte? Aqueous solution of nickel sulfate is the electrolyte here, which will produce this nickel ions. Okay, so I think you understood. This can be a question. And now let us move into the other topic. Another topic is organic chemistry. What is organic chemistry? The definition of organic chemistry, the study of compounds of carbon, or the modern definition is study of the hydrocarbons and their derivatives. Okay, because hydrocarbons are the parent organic compounds and all other compounds are supposed to be derived from hydrocarbons. So this is the modern definition of organic chemistry. Then catenation, another definition that can be asked, is the ability of an element to form covalent bond with its own atoms indefinitely. This also I have discussed under organic chemistry. Under the video introduction, I have discussed this in detail. Then next topic, hydrocarbons. There is a video by the name hydrocarbon. You can see that hydrocarbons are compounds made up of carbon and hydrogen only. Now there is another thing that you have to know is homologous series. A sequence of compounds with a general formula, same functional group and similar chemical properties is known as homologous series. Hydrocarbons are put into 3 homologous series: alkanes, alkenes and alkynes. Now what are alkanes? They have the general formula CnH2n plus 2. They are saturated hydrocarbons because they have sufficient number of hydrogen atoms to satisfy the valences of carbon. They have single covalent bond between 2 carbon atoms. They are less reactive. They undergo substitution reaction. And examples are here methane and ethane. Alkenes is another homologous series of hydrocarbons. The general formula is CnH2n. They are unsaturated hydrocarbons because they do not have sufficient number of hydrogen atoms to satisfy the valences of carbon, and they have a double covalent bond between 2 carbon atoms. Okay, because they are unsaturated, they are reactive, and addition is possible here because they are unsaturated. Addition reactions happen. Example, ethene. Then alkynes is a third series of hydrocarbons, which is another homologous series, CnH2n minus 2. They are also unsaturated due to lack of sufficient number of hydrogen atoms. They have a triple covalent bond between two carbon atoms, highly reactive because they are highly unsaturated. They undergo addition reactions in 2 steps. Okay, and example is ethine. So there is a video by the name hydrocarbon. You can go and see that. There you will find more details about this, and structures are also explained there. Now the next one is, so preparation of methane and ethane from alkyl halide in the laboratory. So that's what we have to see. How do we prepare methane and ethane? So methane is prepared from alkyl halide. Example, methyl iodide, CH3I. Reacts with nascent hydrogen is provided by using zinc, copper couple and alcohol. Okay. So here the nascent hydrogen is produced by reaction of zinc copper coupled with alcohol, and what will happen is CH4 and HI will be produced. So 2 nascent hydrogens will be required. And same way ethane can be obtained by ethyl bromide CH3CH2Br reacting with the zinc copper coupled, here again zinc copper coupled and alcohol. Okay, so what you will get, CH3 that is ethane and HBr. Okay, so this reaction is possible. And then decarboxylation is another reaction where we take the sodium salt of the carboxylic acid, example CH3COONA, sodium acetate, reacting with soda lime. What is soda lime? Caustic soda and quick lime. So NaOH, and quick lime is calcium oxide. So we have decarboxylation. This carboxylic group is totally removed. So you get to CH4 and Na2CO3. So if you take sodium propanoate, CH3CH, one more carbon involved, COONA, and soda lime is sodium hydroxide plus quick lime, that is CaO. Here again decarboxylation. See, this hydrogen will join here. So you get CH3, that is ethane, or C2H6 you can write for formula, molecular formula. This is the condensed formula, Na2CO3. So this is preparation of ethane. Now substitution reaction of methane with chlorine is important. Methane has got 4 hydrogen atoms. So chlorine atom can react in the presence of diffused sunlight. Diffused sunlight, not direct sunlight. Okay. So what will happen? CH3Cl. 2 chlorine atoms, one will go in and 1 hydrogen comes out. So HCl. Now this CH3Cl, which is called methyl chloride, will come here. CH3Cl, again chlorine atom, a molecule of chlorine, diffused sunlight. Okay, 1 more hydrogen will be removed, CH2, CH3 becomes CH2, 1 more chlorine added, Cl2 plus HCl again. Now this CH2Cl2 plus Cl2, 1 more hydrogen will go out, CHCl3, and 1 more chlorine comes in, and HCl. Now CHCl3 plus Cl2 will give CCl4 and HCl. So all the hydrogens are removed by chlorine. Okay, diffuse sunlight you will write everywhere. Now the overall reaction, if you add up this, it will be CH4 plus 4Cl2 gives CCl4 plus 4HCl. Can add all this and this will cancel. Okay, so what will be left? It will be CH4 plus 4Cl2 gives CCl4 plus 4HCl. So this is when excess of chlorine reacts. 1 mole of chlorine, first product, methyl chloride. Then methylene dichloride, this is chloroform. And this is carbon tetrachloride or tetrachloromethane, the IUPAC name. Okay, so this is a substitution reaction of methane. This is important. Please study this. Then preparation of ethene by Dehydrohalogenation reaction. How do you prepare ethene? Dehydrohalogenation, removal of hydrogen and halogen. So what you will have is CH3, CH2Br, ethyl bromide, plus what you have? Dehydrohalogenation. What will be the substance that will be used? Alcoholic KOH. Okay, so alcoholic. So the potassium will remove the bromine, and one of these 3 hydrogens will go with OH. So you get CH2 double bond CH2, which is ethene, plus KBr plus H2O. So this is a reaction. Now ethene is unsaturated. What are the reaction? Addition of hydrogen, CH2 double bond CH2. You can add hydrogen to this. Now how will it add? You can send one hydrogen to this carbon and one to the other. So it becomes CH3, CH3. So ethane will be produced. Ethene's unsaturated hydrocarbon changes to saturated hydrocarbon, ethane. Okay. Then addition of bromine is another reaction. CH2 double bond CH2 plus Br2. Okay, there is a video by the name of alkenes. You can check that. There everything is dealt with in detail. So carbon tetrachloride neutral solvent is used. So it becomes CH2Br dash CH2Br. Okay, ethene. Now bromine will be purple colored. This will be, final solution will be colorless. This is called 1,2 dibromo ethane, saturated hydrocarbon. Okay. Now the next is preparation of ethane by dehydrohalogenation and calcium carbide. Dehydrohalogenation is a method for preparation of ethane. Okay. So we will take here C 1,2 dibromo ethane, CHBr and CHBr or CH2. Okay, 1,2 dibromo ethane, or you can write CH2Br, CH2Br this way. Okay, and what you will do? You will use KOH. KOH, 2 molecules of KOH will be required. So KOH and KOH, alcohol. This KBr will go, and again KBr will go. The OH will take 1 hydrogen from here. So 2 KBr plus 2 OH is there, 1 hydrogen is removed, so it will form 2 H2O. What is left will be carbon with 1 hydrogen. So CH triple bond CH will be formed. So this is ethane. Okay. So this reaction is important. They can ask you. And the next method of preparing ethane is from calcium carbide. Calcium carbide is a cyclic compound. So C triple bond C and Ca and Ca. Calcium carbide, CaC2. It will react with 2 molecules of water. Water is HOH. Okay. So the bonds break like this. Okay. So what you get is CaOH whole twice. 2 OH groups combining with calcium, and what is left behind is HC triple bond CH. This is ethane. Okay. Then the reactions of ethane, addition reaction. Number 1 is addition of hydrogen, CH triple bond CH. This is ethane plus 1 molecule of H2. Hydrogen 1 goes here and 1 comes here. So it becomes CH2 double bond CH2. So this is ethane and this is ethene. Now the ethene will again combine with another molecule of hydrogen. 1 hydrogen goes to this carbon and 1 goes to this carbon. So you get CH3 single bond CH3, which is called ethane. Okay. So this is another important reaction. Then addition of bromine. Bromine addition can also happen in 2 steps. Br2, you will use CCl4. Here you will have 1 bromine goes to the first, 1 goes to the next. So CHBr double bond, one of the bonds break because of the addition of bromine. So the product is 1,2 dibromo ethene. Okay, naming also was discussed in structure and naming. I have nomenclature I have discussed in another video. You can see that. Now this compound 1,2 dibromoethane can undergo one more addition of bromine, CCl4. So here you have CHBr2, single bond CHBr2, which is known as 1,1,2,2. Tetra hyphen here, tetrabromo. 4 bromines are there. Ethane, tetrabromoethane. So this is another important reaction. Now the other important topic in this is the isomerism. What is isomerism? The definition: phenomenon in which more than one compounds have the same chemical formula but different chemical structures. Now different isomerisms: chain isomerism and position isomerism. You must know what is chain isomerism. If you write a structure like this, CH3, CH2, CH2, CH2 and CH3. So 1, 2, 3, 4, 5. So this is pentane. Yes, we already know. And CH3, CH3. So this is 2-methyl butane. Both have the formula C5H12. Okay, C5H12. This also has the same formula, but the length of the carbon chain, this has 4 carbon chain, this is 5 carbon. So that is chain isomerism. They are different structures, chemical formula same, and due to the difference in the length of the carbon chain. So that is chain isomerism. Position isomerism is, so when you have a functional group or a substituent in different positions. Example, CH3, CH2OH, CHOH and CH2, CH3. So there are 5 carbon atoms here. So this is pentane with the OH group. So it will be pentane 2 all. The OH is in carbon 2. Number is from here. Okay. Now this isomer of another isomer of this is CH3, CH2, CHOH, CH2, CH3. So 1, 2, 3, 4, 5. So this is pentane 3 all. The structure is different due to the difference in the position of the functional group. So this is position isomerism. Okay. So in this video, this is all. I will have another video coming up with some more important topics. Please do not skip any of these topics because they are important for your examination. Thank you for watching.